Okay, now I want to talk about Apache Kafka, and then I will move towards the Spark streaming more details. So, I want to introduce you first what is a messaging system, and there are two types of messaging system. One is called point to point, the other one is called publish subscriber messaging system. Kafka uses publish subscribe model. So, we will talk about that more details, and then I will introduce you this Kafka terminology. And then at the end, Salam will show you the Kafka setup. So, what is a messaging system? A messaging system is responsible for transferring data from one system, one application to another. An application will not involve in how to share the data. And there is distributed messaging system. We have point to point and publish and subscribe. Point to point means sender will send the messages and it will go to the queue and receiver will consume from there. And one or more consumer can consume the messages from the queue, but if once a particular message is consumed, it will disappear from there. So, in point to point case. And then on the other hand, there is another model which is more robust called publish subscribe messaging system. Messages are persisted in a topic, and consumer can subscribe to one or more topic and consume all the messages in that from that topic. Message producers are called publisher and message consumer are called subscriber. So, here you can think about producer produce the messages and they produce the messages in terms of the topics. Under the topics multiple message it can post. And then this topic, so now the Kafka is in this part. So, the topic producer can come up with many topics. So, each topic will be divided into a number of partitions, and each partition in the system will keep multiple copies, because we need to make sure that the system is fault tolerant. So, again how we guarantee that the system will be fault tolerant? We always say we want to make sure the system is fault tolerant through the replication. So, here same thing. So, when producer produce the messages, the idea here the message should not be lost. Message should not be lost during this transfer from the producer to the consumer. So, for that what we do, we keep multiple copies basically. So, here I said the topics will be each topic will be divided into a number of partitions, and each partitions will keep multiple copies in the system. So, that is a very basic idea at this point. So, Apache Kafka uses that publish subscribe messaging system. Kafka is used as an enterprise messaging system to decouple source and target system to exchange the data. Kafka provides high throughput partition with fault tolerance in replication. So, this is a Kafka clusters. Basically, a number of machines will form the Kafka clusters that will facilitate the messaging system, and then these are the sources that produce the messages, and these are the target that consume the messages from these Kafka clusters. And Kafka was developed, as I told you, by LinkedIn. So, Apache Kafka is a distributed publish subscribe messaging system. It is a robust queue that can handle high amount of data. Kafka maintains feeds of messages in topics. Producer write the data to topics and consumer read from the topics. Since Kafka is a distributed system, topics will be partitions and replicated across the multiple nodes. So, again keep in mind that this Kafka cluster will consist of number of machines. Now, these machines will hold the data. So, when the producer produce the messages in terms of the topics, so it will be the topics will be partitions, and a topic may maintain multiple partitions, and those partitions may be replicated. That is the key point I am trying to make. So, here the one point, let us say a producer produce some messages, basically producer will push the data, and then in this case the particular under particular topic, let us say we maintain 3 partitions, and so each partitions we maintain some offset where the data will be written. Within the partition, data will be written one after another. So, there will be a certain order will be maintained within the partition, and each of this partition can be replicated based on your replication factor. So, if I say replication factor is 3, that means this partition 1 will be stored into the 3 brokers. In this case, when I use the term brokers, keep in mind that basically it means that each individual machines are node. So, one broker means one machine. So, now I said data will be written in terms of the topics, and underneath topics is a logical name, just think about that. Underneath now we need to store the data, right, in the Kafka cluster. So, underneath just think about this topics will be will create multiple partitions, and the topic will go to one partition. I mean, I'm sorry, the topic will have more than one partition, and each partition will have more than one copies based on the replication, and then those copies will be stored into the defined machine. Let us say replication factor is 3, then partition 1 we will keep 3 copies. So, the one copy will serve as a leader and the other 2 copies will serve as a follower. Those 3 copies will be stored into the 3 different brokers or 3 different machines. That is the point I am trying to make. Is it clear? So, the topics will be, a topic is a stream of messages belong to a particular category or logical name. Topics will be split into partitions, and each topic Kafka keeps one or more partitions, and each partition has a unique sequence ID called offset. So, here you can see producer write the data, and each of the producer will maintain an offset. So, it will write not each producer. So, for each partition there will be a offset. So, each partition there will be offset that will be used by the producer. So, let us say at this point for the partition 0, the offset is here, that means the data will be written after this. So, partition 1 same way, partition 2 and so on. So, topics are identified by name, the order of the messages in maintained within the partition, not across the topics. And once the data is written to that partition, it is not overwritten, that is called immutability. The message in partition are stored with the key value pairs and the timestamps. Kafka ensures that publishing the message to the same partition for a given key. And from the Kafka cluster, each partition will have a leader that will read and write the operation for that partition. And the brokers is the backup of a partitions. I'm sorry, I made a mistake. The replica is the backup of a partition. Yeah.
Yeah. Sorry, when you said that it's not when the order messages isn't maintained across the topic, is that per topic or across all topics? So, like for one topic, the order of the messages.
Yeah. So, it's a very good question. So, one topic, let's say I maintain, the system maintains 2 partition, and the replication factor is 3. So, there will be a total 2 times 3, 6 copies, 6 partitions, and that will be spread across various brokers. Now, within the partition, the order will be maintained. So, now the problem is there is a possibility that across the 2 partition the order may be defined. Yes, there will be no order. So, now keep in mind that when you create the data with the key value pairs, so it will go to one particular partition, right, very likely. So, and within that partition the order will be maintained based on the timestamp. So, in that case certain order will be preserved. But if you try to combine 2 partitions messages together, then from the 2 partitions the problem is, let us say I have 2 partitions, and in partition 1 and partition 2 we maintain the system will maintain the order of the messages. But if you take the union, it does not matter in that case, because do you think the same message will not go to the 2 different partition? No. When it comes, the message will come with will apply the hash, and then it will go to a one particular partition, and that is it. But for that partition we may keep multiple copies.
But so if you needed to maintain order, you need to make sure that the keys are the same for those
Right, yeah. Any other question? Okay, so Apache Kafka, the replica is backup. So again, the high level picture is you have a topic. Under topic, you have a so the topic is a logical name. So the topic will be multiple partitions will be created, and data will be the key value pairs will be stored there. And now each partition we will keep multiple copies in the system. And if I have a, let's say if I have a 3 machines. So Kafka cluster has 3 machines. So I can create only 3 partitions for each partition. I can keep 3 copies. Why is that? Because each partition will have 3 copies and 1 copy will go to one particular node. So total 3 partition will be created, will be distributed across 3 partitions. But I cannot say the replication factor is 4 for a partition, because I do not have 4 machines, I have only 3 machines. That is the way this constraint is enforced. Yeah. What is?
I wonder why just 3?
I give you an example. So you can say 2, that's also fine, because you have 3 machines at most. So replication go at the replication factor will be controlled by how many machines you have or how many brokers you have. Per broker, each machine will serve as a single broker. So here this diagram will tell you more details about that, what I try to say. So here let us say we have a topic 1, and the topic 1 has a 3. Okay, so the topic 1 has a 3 partitions, partition 0, partition 1 and partition 2. So in this diagram, and we have a, let us say Kafka cluster has 3 brokers or 3 machines. So what will happen for topic 1, I said 3 partition, partition 0, partition 1, partition 2. Partition 0, I am showing you more details. So partition 0, the broker 1 will serve as a leader. So when the message comes, if it go associated with partition 0 after partition hash, after applying the hash, it will go this node will serve as a master or the leader. And then these are the other 2 brokers will also store the partition 0's copy, but this will serve as a follower. Now the topic 1, I said 3 partitions. So first partition, this one is a leader and the rest will serve as a follower. And partition 1, in this case the broker 2 or the machine 2 will serve as a leader, and partition 1 has 3 copies total. So these are the 2 followers. Similarly, partition 2 has a leader will be in the will be stored in broker 3, and the follower will be in the broker 1 and broker 2. Then, so that way data will be stored. Now the consumer will needs to consume, and consumer, let us say this consumer, there are 2 consumer form a group A. There are 2 groups here in this case, consumer group A, consumer group B. For each group there will be offset. So for this partition, the data consumer A, group A and consumer group A and consumer group B will consume the data. So consumer remember the offsets where they left off. So in this case the consumer group A was consumed from this up to this point, so it will remember that, and consumer group B will reads from here, and the producer will produce the messages. So this is the producer offset. So that way we maintain the index or offset where producer will produce the messages, that means the message will be added after this, and consumer will start to consume at its own rate like this. Now, this diagram tells you that server 1 or broker 1, broker 2, broker 1 has a 3 partitions, partition P2, P3, P4, and server 2 has a broker 2 has a partition P0, P1, P5, and consumer group A and B, consumer group C0 consumer, it consumes the data from partition P2 and it from the P0 from server 1 and server 2 respectively. Similarly, C1 consumes from partition P3 and P1 P1. So, one important point here in this diagram is this: a particular consumer in a particular group, a consumer can consume. So, this case I am trying to say that let us say we consume the message from partition P2 by C0, then from the same group C1 cannot consume the message from the same partition. That is the point, in order to make a better balance. And then Zookeeper will be used for the coordination purpose. Because this is a distributed application, Zookeeper is used for managing and coordinating Kafka brokers. Zookeeper is mainly used to notify producer and consumer about the presence of any new broker in the Kafka system or about the failure of any broker in the Kafka system. And then here I try to tell you that the producer will use the push model to push the data into the Kafka clusters, and the consumer will pull the data based on the offset. And Kafka is a fast, scalable, durable, reliable, published subscriber messaging system, and these are the features we have. Scalability means there will be no downtime. Durability means distributed commit log will be used. Reliability means it gives you the partition, replicated, and fault tolerant system. Performance, Kafka has a high throughput, both publishing and subscribing messages. And it gives you real time, it processes the data, handles the data in real time, so it helps you to achieve the real time analytics. And Kafka can work in combination with the Flume, Spark streaming, Storm, all this framework. And then now he will tell you a little bit more, Salam will tell you more how to set up the Kafka clusters. Unfortunately, you don't need to worry about, fortunately you don't need to worry about that, because that cluster is already working in our setup. Yeah, you want to use that?
Okay, I can use it.
Thank you.
As Christopher said, already the Kafka software has been installed in your PC. So whenever you are at your own convenience, you can download this software and install it by yourself in your respective laptops or respective machines. But for the current machines, it is already there. Now, basically we will show you how to run the Kafka server from the beginning. And so this is the step where you run the Zookeeper server first, then you start the Kafka server. So to start the Zookeeper server, you have to use this command. You want to run the Zookeeper server with this file, and you specify the configuration with this properties file. So if you want, you can start a terminal and go to this directory. First do a command like this, change directory to $cd $Kafka home. Kafka underscore home, all capital. You should be able to see that you are moved into a new directory where the current Kafka has been installed. From there, if you have a terminal, you can run this command by yourself to start the Zookeeper. this command is used to run the Kafka server start. You have to open another terminal in the same directory and you can use this command to run the Kafka server itself. So, once you have your systems running, we can check what topics are available within the Kafka with this command, and you should be able to see the list of topics that has been already created. So, the key argument here is the list command, and you also specify the zookeeper server location with this attribute. So, once you are able to run this command, you should be able to see the list of topics you have in the Kafka. Then if you want to create your own topic, you can use the command here above, where you will specify the name of the topic here under the topic attribute. So, you can use the test, the name test, or you can use your own. So, I think you are able to run the second command, the command to create the topics with a particular topic name. Once you have created the topic name, I would like you to open a terminal and try to open a Kafka console consumer. You specify the topic name you have created with the topic argument, so that you can see the messages published under that topic. First create the consumer, then we will start producer and type our own message, and we should be able to see it in the consumer terminal window. So, create a new terminal and run the Kafka console consumer.sh. Again, you have to help it identify the Kafka location, which is localhost 9092 port is used by Kafka, and this form beginning argument specifies that you should read the messages that has been published to at the very beginning, not like just published after the consumer started. Then to produce messages for this window, we will create a producer in separate terminal with the following command. And again, you have to specify the Kafka location you want to use, where the Kafka server is running, and the topic you want to publish messages to, which is in your case, I mean the topic you have just created. Then it is a command line window where you can actually give input. So, whenever you write something and hit enter, it will be considered as a message, and you should get the output on the consumer side. So, just run and see if you can see the messages on the other terminal. once you are comfortable with these examples, that ends this module, and we will focus on the Apache streaming part, more details, and professor will give you lecture on that session.
So since I have only 9 minutes, I will continue with the where I left off from here, and then after lunch break we will start with the Spark streaming, and then how to process the articles from the Guardian website and do the classification on the fly using Apache Kafka and Apache Spark. So the last part of the lecture, what I try to say, that Kafka can be used as a publisher and subscriber messaging system. So there the producer will produce the messages in terms of the topics. Topics you can just think about logical name, and underneath Kafka cluster will maintain a bunch of machines, and so each of this machine will be known as a broker. So when the producer publish the messages in terms of the topics, each topic will maintain multiple partitions, and each partitions we can keep multiple copies, and usually each copy will be stored one single broker or server. So now each partition, we said you can have multiple copies, but based on if your number of machines or the number of brokers, the replication factor will be controlled by that. So replication factor can go all the way to maximum number of brokers or servers you have in the Kafka clusters. So if you have a Kafka cluster has 4 machines or 4 brokers, then you can set up your replication factor all the way to 4 at most. But you can set replication factor 1 or 2, that's also fine, as long as if it doesn't violate the maximum number of brokers or servers. So again, the point I'm trying to make, we have the topics, and the topics is a logical name. Topic will be distributed across many partitions or number of partitions, and each partition will keep multiple copies in the system. And one of the copy will serve as a leader, and the rest of them will serve as a follower. And then within each partition, we will maintain offset from the producer perspective, and then from the consumer perspective, we have many groups, and for each group, we will maintain a offset per consumer group. And then another important point I am trying to make, the order of message is maintained at the partition level, not at the whole topic level. And then once the data is written to the partition, it is not overwritten, it is immutable. That's another point, and the message in the partition will be stored with the key value pairs and the timestamp. And then the last point I tried to make in the past, that there are 2 consumer group here. So consumer group A consumes some messages from some partitions from server 1, some partition from server 2. But in this case, when consumer C0 consume messages from partition P2, at the same group C1 cannot consume the message from partition P2 also. Why is that? Because if you remember, per group we maintain an offset, right? For a per partition, per group we maintain offset, right? So that's why that's one of the reason. When we consume the message, the the offset will be incremented. And then, yeah.
When after the topic is put in multiple partitions, how do you decide which partition to put the messages in for that particular topic?
So the message usually comes with the key value pairs. So you will apply, let's say, the topic is test, and you have a 3 partition P0, P1, and P2, and you create a message. Message will have a key and the value. So now the key you will, so it's similar to like Hadoop, what we do, apply the hash and then 3 partition, right? You have hash, key, mod, number of partition. So total partition 3, right? So it will give you a number between 0, 1, 2. So if it is, let's say it gives you, after applying the key on the key, apply hash mod 3, it gives you, let's say, the 1. So that means it will go to the partition P1, something like this. So this is one way you can do it, and there are other ways also you can, other policies you can enforce. Any other question? Okay, so now after that we will move towards, not now, but then we will start with the Apache Spark streaming after the lunch break, and then after that we will start hands-on immediately. So it will take another hour and then we'll start hands-on after the lunch break. So now I want to give you lunch break today. So let's have a lunch, and today we may have a different lunch, different types of lunch. Okay, so please go to the same place and enjoy your lunch.